In this lesson, I'll give you an overview of the API Demos application chapter. I'll outline the lessons included in the chapter and give you a quick look at the API Demos app itself. The API Demos app, shown here in the emulator, is included in the sample apps. It provides a simple demonstration of over 300 Android features and includes many tens of thousands of lines of code. This gives you, as an Android developer, access to application code patterns that can speed development and provide insights into the functioning of Android APIs. The API Demo app is a bit different than the apps we've used so far in the course. It's much, much larger, and it's included in the emulator. You shouldn't need to run the app using the emulator debugger to see it function. I'll explain more about this shortly. So let's take a look at it. We click on the app. We see the app home screen shown here that lists the primary categories of API demonstrations. These include accessibility, animation, app, content, graphics, media, NFC, OS preference, text, and views. And we'll be going through each of these in detail. So for the moment, don't worry about exactly what each category means. Some of the categories are divided into subcategories. For example, if we click on animation, we find another group of about a dozen or so demos. If I click on, say, bouncing balls, it brings up a demo that shows an animation of bouncing balls when I click on the screen. In the chapter lessons, I'll show you how to navigate around the app, find the demos you need, and locate the source code in Eclipse. Now, if I click the back button, I can get back to the home screen. And if I click back again, it takes me to the launcher. And if I click back again, the home screen for the emulator. Now in my launcher home screen, I've included the API Demos app. So let me show you how to move the icon to your home screen if you'd like to do that. It's a convenient place to have it. So you're probably familiar with this already. But let me remove the one that I have there already. Go back. Click and hold, and place it on my home screen. Now you should be able to find this app preloaded in your emulator. However, you still need to load the app into your Eclipse workspace. So let's look over here in Eclipse, and you see I've already loaded the API Demos app. We'll go through this in just a moment. To get the API Demo app loaded into your workspace, you have a few options. First, you can use a wizard. To do that, you'd click File, New, Other, and click Android Sample Project. Next, select the target. I'm using Android 4.2. Click Next, select API Demos, and then it's already loaded in my workspace, so I can't click Finish. I'm going to click Cancel, but you would click Finish and it would be loaded into your workspace. Another option you have is to use the Working Files Samples Workspace API Demos app. You could use a wizard to load it into your own workspace or use the Sample Files workspace. Once it's loaded, you can expand the folders to see the contents. And there are a large number of files in many of the app folders. And let's look at the source folder first, which we see here, which I've already expanded. And you'll see a series of additional folders. And these represent the main categories of the API samples. So let's go back and open up the API Demos app again. You see those main categories. So you see this is the code for the app overall running the main screen. And then you see how we have accessibility, animation, app, and so forth. There are a couple of additional folders, like Cube, which is associated with graphics, but we'll leave those details for a later discussion. Let's take a look in the animation folder. I've expanded it, and we see the app demonstration Java source files. And remember our bouncing balls example we looked at. Let's bring it up again. And the corresponding file is here. Happens to be called bouncing balls. And if we double-click on that, then we get the code here in the center window. And if you were including the bouncing balls in your app, once you found the Java code, you might use the entire Java code file as a starter for your app, or you might use pieces of it, or you might just want to understand how a bouncing balls display is created. And now let's take a look at some of the other folders. For example, the resources folder. In the animation subfolder, it's quite large. Drawables. There's a lot of entries. Layouts. And menu. And we'll be looking at a number of these in detail. Right now, I'm just giving you a look at the general organization and scope of the app, and as you can see, it's large in many aspects. In this chapter, I'll show you how to use the API Demos app to improve your knowledge of Android and find code to seed development of your applications. I'll show you how to use an Excel API demo worksheet I created that details the organization and content of the API Demos app so that you can find what you're looking for. In this lesson, you'll learn how to use an API Demos worksheet to locate API functions and code you can use to seed development of your own Android applications. With over 300 function demos and many tens of thousands of lines of code, the API Demos app can be hard to navigate to find a feature you're looking for. And it's also a challenge to find the source code associated with a given feature. To help deal with this complexity, I've developed an Excel worksheet, shown here on the left, which is included in the working files for the course. It details all the levels of demo organization and shows how each demo relates to the app Java source code. Let's take a look at how it's organized. First, each demo screen is represented by an entry in the worksheet. So, for example, we see our bouncing balls demo on line 6. There are 4 columns: home screen primary group, secondary group, tertiary or third group, demo name, and Java file name. All the entries have at least a home screen primary group name, demo name, and Java file name. Some have an additional secondary group category, and some even have a third, as we see down here. In some cases, the Java file name is similar to or the same as the demo name. In some cases, it's very different. For example, if we look down in the views entries, starting in line 175, we have a Java file name of animation1 instead of something like the demo name shake. In most cases, the primary group name is the same as the 5th level of the source folder name. For example, the accessibility group is located in the com.example.android.apis.accessibility folder here in the file structure. And there are a small number of exceptions. I've noted these in the Java file name column. For example, in line 106, the graphics cube file is located in the graphics.cube folder. Now down at the views entries, let's look at the animation views to show you 2 levels of grouping. In the emulator, click on Views. We do this because we're looking at a view animation, not the group of animations located in the animation primary category. So we've clicked on Views, and we see the next levels of organization. Each of these could be another organization group or a demo itself. So let's click on Animation, and we see 4 names. If we click on 3D Transition, we see the demo itself. It looks like another group, but it's the actual demo. If we click on Lyon, we see a photo. Click on the photo, we go back again to the list. We click on Livermore, see another photo, and so forth. In the worksheet, notice the missing tertiary or third level of organization for the animation group of view demos. We went straight from the secondary group to the demo itself. Now let's go down to line 210, where we see entries that have all 3 levels of groupings. So let's go back to the demo app and look at Views, Layouts, Baseline, and Bottom, and we see a demo of buttons at the bottom of the screen. Now let's go back to this level here. See these numbers, 1, 2, 3, 4, 5, 6. I've omitted them from the demo name column because they would mess up sorting for the column. See the entry at line 210 for the bottom example we've just looked at. The Java file name is baseline 2. And now over to Eclipse, and we'll look at the View folder. And here's the baseline 2 file. If we open it, I have it open here, we see it's very simple. It sets the content view using the baseline 2 XML file. And we can go down and find the baseline 2 XML file here in Layouts. I have it opened up over here. And if we click on the Graphic Layout tab, we see the graphic version and the XML version showing the actual XML. Now let's go back to the worksheet. I told you that there were over 300 functions demonstrated in the app. We can scroll down to the end to verify that number. We see that there are 303. Actually, it's 302, given that we have a header row. How the heck can we hope to find the right code given all these possibilities? There are a few different approaches. First, after we've gone through an examination of each of the primary groups of demos in the following chapters, you'll have a better feel for what's included in each group. So you might remember, for example, our bouncing balls demo, and that it's included in the animation primary group. But with over 300 entries, it's unlikely that you can remember all of them. I know I can't. So here are some other ways to find demo app functions. First, there's sorting. To use that, first click in the upper left of the spreadsheet to select all the cells. Next, click on the Data Sort button. Within that window, click to check that your data has headers, which I have clicked there. And you see our header names off to the left. And currently the data is sorted by the first 4 columns in their order. But let's say we want to do a sort on just the demo name so that we can get all the entries listed just by the demo name. So we can delete all but the demo name and click OK. So now we have a list that's sorted by the demo name. Now let's go back to the sort that we had. So we click on the upper left, click Sort. I'm going to add back levels. I'm going to sort by primary home screen, then secondary group, tertiary group, and finally demo name. Click OK. So I've gone back to the original sort that we had, sorted by the first 4 columns. And another way to sift through the demos is by using the filter capability. We click on Data, Filter, and we see some drop-down buttons appear. Now let's click on the demo name drop-down, and we can add some text. Let's add the word custom, and click OK. And it now shows the entries that have the word custom in the demo name. And if I click the filter button again, we go back to our original view. So why bother with the worksheet? Why not just use the API demo directly? The reason is that there is no overview of the entire contents or sorting or filtering capability built into it. And it's difficult to impossible to hold the entire organization with its 3 levels of grouping in your head. The worksheet is a sort of map to facilitate getting to the right code for the task at hand. That's our lesson on the worksheet, and we'll use it continually as we work through each group of API demo functions. And one additional comment, as Google develops new Android releases and adds to the API demos, you might want to update the worksheet to keep it current. In this lesson, you'll learn how the API Demos app fits into the course and how you can use the API Demos code in your apps. This graphic shows the outline of the contents of the course, and the API Demos app fits into the App Components and APIs group. It's also a gateway to understanding all of the other groups we'll cover in future chapters. App Resources, Media and Camera, Web Apps, Remote Access, User Interface, Connectivity, Location and Sensors, Data Storage, and Animation and Graphics. And we'll be using the API demos coupled with other sample apps to cover these topics. This graphic shows how the API Demos app groups intersect with our course groups. As you can see, in some cases, the API demos cover more than one course group, such as content covering app components, app resources, and data storage. And in some cases, a course group like user interface is covered by multiple API demo groups. For example, the user interface is covered by API demo accessibility, app, preference, text, and views. With this expanding list of possible coding options, how will you possibly be able to make choices about what code to use? To understand this, let's take a quick look at the development process. And most apps begin with some kind of conceptual design. This can be anything from a napkin sketch to an elaborate set of design documents. But there's usually something to start the development process off in a certain direction. And next, there's usually a design phase. The Android developer's website has a lot of good material for feeding the design phase. This is a course on code development, so we won't be going over this material in any great detail, but it's good for you to be aware of what's there. There's material on creative vision, design principles, and UI. There's a style section dealing with the look and feel of app displays. There's a patterns section covering how the user can move around within an app, and a building blocks section on the basic moving parts such as tabs and lists. And we'll refer back to some of these sections in later chapters dealing with specific capabilities. But overall, this material can be very helpful in pointing you in the right direction for finding and developing code. For example, in the page on buttons, there's a description of button options. If we go to our worksheet, go to Data, Filter, and we filter on Button, we see a couple of entries that we could explore for button handling code using this Java source. As a general view of finding the right code design patterns, we've now looked at a number of sources for information: the developer's website, the API demos worksheet, sample projects, and web search, including the Stack Overflow website. With some system knowledge, the use of keywords, and research efforts, you should have some good success pinpointing the right design pattern for the task at hand. Now, once you find it, then what? To understand the answer to this, let's look at some code pattern elements. The full details of each code sample and pattern can be vastly different one from the other. However, there are common piece part types that can help you organize your approach to using the code. Now, these include classes, methods, returns and parameters, variables, assemblies and calculations, resources, and code sequencing. It can be intimidating to confront a large code design pattern. They can be hard to understand at a glance. Breaking them down into pieces will help you digest the content and figure out how to apply the code to your own applications. Now, this is the kind of breakdown we did in the lessons on the 4 component types: activities, services, content providers, and broadcast receivers. How you approach a code pattern can depend on its size, your knowledge of Java and Android, and the requirements for the application you're developing. In some cases, it might be best to start digesting classes you haven't used before. You might use the Android developer's website API guide and class reference sections. In other instances, for a large code pattern, you might start by digesting the sequencing of methods and statements. Going forward, we'll leave some of the sample app code analysis for you to perform. We won't have time to explain all Android capabilities to the same level of detail we did with the 4 component types. This kind of analysis is a skill you'll need in order to develop Android applications. Remember, you have lots of resources you can use to understand code patterns and their piece parts. You just have to take a deep breath and dive into the details. This is the first of 2 lessons in which you'll learn how to add code to your Android app. As we've seen in previous lessons, there are a number of resources we can use to help create new code, including the developer's website, API demos and worksheet, Android sample projects, and web search. In this lesson, we'll tap into these resources to help us add an enhancement to our first app project. To refresh our memory, let's start our first app. In Eclipse, I'll highlight the first app project and click the debug button. And we see our simple line of text displayed. Now we're going to add to our first app. Let's say we've seen ratings used in other apps and think they might enhance our app. So we decide to add rating stars to our app. First, we do some research. Let's start with the API Demos worksheet. In the worksheet, let's search the demo name on rating. And notice as we add characters, the selections picked up show down here. And as I add an S, it shows no items match our search. So what I'm going to do is back off and use the singular rating. Click OK. And we get a hit in the primary group views of rating bar with the Java file name rating bar1. So let's fire it up in the emulator. We'll start the API demos, and in views, click rating bar. So what do we see? We have a couple of rating bars at the top, one with 3 stars, one with 5, and then others down here. As we click on the bars up on top, we get an average rating showing down here. And notice we can click on whole stars or half stars. Now let's look at the rating bar code. In the API demos source, in views, we'll click rating bar 1, open that. And what I like to do first is just scan quickly through code to get a rough feel for it, how long it is, how complex it is, what classes it's using, etc. So we see there's about 75 statements, not too complex, it doesn't look like. Looking at the display it creates, it's doing some things that we might not be interested in, such as displaying an average rating of the 2 bars down here. So we probably won't want to use all the code from this demo activity. And let's expand this out. In line 29, we see that our main class implements the rating bar on rating bar change listener. So we make a note that we might need to add this interface to our existing class. Lines 30 through 32 define some variables used below. Line 35 defines our onCreate method. Line 38 initializes our display using the rating bar 1 layout. So let's take a look at that. In the layout folder, we'll open rating bar 1. And we see it defines a number of rating bars. 2 here, more down here. And let's look at one of them. In lines 23 through 27, it defines a single rating bar. So it looks like we want one of these in our app. Now let's open the layout of our first app enhancement. I've already created a new app in the working files workspace called First App Project Enhancement. So let's open the layout. And if we look in the graphical layout tab, we see where I've added a stars bar up at the top. Now, the way I did it was using the form widget. I simply clicked on the stars bar and dragged it onto the screen. And I can just simply undo my operation. I'll use a Control-Z characters. And this is a handy way to play around with adding elements to your screen. If you don't like what you've done, you can just undo what you changed. Now let's look at the XML tab, and we see that in line 15 of the rating bar that was added, the ID is rating bar 1, and we'll need that in our Java code to refer to the rating bar. Also notice that there's no num stars or rating attributes included in our XML. In the rating bar 1 XML, we see that there's a number of stars and rating included here. So it looks like these are optional attributes, and we'll leave them out for now. That's the first of our 2 lessons on adding code to your Android apps. Let's move on to the second lesson. This is the second of 2 lessons on adding code to your Android apps, and we'll pick up our analysis back in our rating bar 1 Java code. Line 40 gets the text view of the rating text field in the layout. Lines 44 and 45 set variables for 2 rating bars from the layout. Lines 48 and 49 set on rating bar change listeners for rating bar 1 and rating bar 2. Let's expand this out. Line 52 declares the onRatingChanged method that's called when a rating bar is changed. This call is built into the interface we implemented in line 29. Lines 53 through 71 set the text and rating bar in the lower part of the display here. So we may not be interested in this code for now. What this points out is that you don't have to analyze every line of a sample app to use pieces of it. Now let's look at the Java source code for our new project. In the source folder of our first app project enhancement, we'll open the main activity. I'll point out the new code and explain my logic for including it. Line 10 defines our main activity, which now implements the onRatingBarChange listener interface. Notice that in lines 7 and 8, we've imported the rating bar and onRatingBarChange listener classes. Lines 14, 15, and 18 are unchanged from our original app. They declare the onCreate method and initialize our display. Line 21 is a statement that's been added. It sets up a listener for our rating bar. It was taken from the rating bar 1 Java from line 48. In this statement, in our new app, we had to change the lowercase b to an uppercase b to match the ID in our new XML here. Line 25 is also new. It declares our onRatingChanged method that'll be invoked when a rating bar is changed, and it was taken directly and unchanged from the rating bar 1 demo. And if we hover over the method name, we can look at the parameters. Rating bar is the name of the rating bar whose rating has been changed. Rating is the current rating, which we'll use below in our code. And from user is true if the rating change was initiated by a user. Lines 28 and 29 is code from our original first app project that logs a message. In this case, we've changed the toString parameter to our rating parameter, and we're now using the float class because the rating is a floating point number. So let's fire up our new app in the emulator, highlight the project, click the debug button. So here's our enhanced app, and we have a rating bar which we can change. And in the debug window, we click on the debug tab and make sure that we've checked the right project, because we want to look in the log file here. And I'm going to expand this out. As we change the stars, you see we get a new message indicating the rating. And this comes from our log code here. And it's here in the Java code that you would do the work using the rating in your app. And to continue on, lines 31 through 38 define the onCreate options menu, and this code is unchanged from our original app. Now I'd like to make some general suggestions about adding code to your apps. I like to add code in smaller rather than larger chunks. It's normal when adding code that errors are introduced. If you add a large section of code, it can be more difficult to isolate and correct errors than with smaller code segments. For example, in our enhanced app, you could add the implements onRatingBarChange listener before adding any of the code to respond to the rating bar. If you hadn't added the needed imports, this would have introduced errors that you could then correct before adding more code. So for example, if I comment out these imports, you see the error indicators appear. And if I click on the error, it tells me to create the imports. So if I go back and take out the comments, you see the errors disappear. Now I have an error-free app before moving on to adding more code. If your app is already running error-free and you add a code segment, any error introduced is likely due to the code that you just added. Adding small blocks of code make it easier to back out the code if you aren't able to get it working and want to try another approach. Also, after each addition of code, I'd like to get the app functioning again. Don't let errors accumulate. Multiple errors usually increase the difficulty of debugging. And in addition to letting the compiler check for syntax errors, as we've been doing here, you should run the debugger after your changes to check for execution errors. So, for example, we would save any changes we've made, click the debug button, and the app is started up again. To help with code comprehension, I like to use code comments fairly liberally. Even if you understand some lines of code at the moment, when you return to the code after the passage of time, you may have difficulty understanding it or understanding it quickly. Code comments can also help design your code even before you have actual code to add. Sometimes you'll figure out that a type of function needs to be performed, but you don't yet know how to code it. In that case, go ahead and add a comment using the best description you can, and then fill in the code later. For example, in line 20 of our enhanced app, you might have known or guessed that you needed to set a listener for the rating bar, but didn't know yet how to code it. So you could add the line 20 comment and then fill in later with the code in line 21. In addition to the API demos, there are other resources on the developer's website you can use. For example, on the developer's website, if we search on Common Tasks and click on this first entry, we get a page with a number of common tasks explained with code samples. And Google is adding new resources to the website all the time. One way to stay up to date on Android development is using Google+ to follow what's happening with Android developers. If you sign up for Google+, you can follow Android developers. And there are lots of posts by the Google team and others on the latest and greatest Android features. That's our lesson on adding code to your Android apps. In the chapters and lessons to follow, we'll look at a number of design and code patterns you can use and adapt to your applications. In the User Interface chapter, you'll learn how to develop user interface displays and have your Java app code interact with display elements. The user interface is an area of heavy intersection between app design and app development. The choices made for user interface elements have as much to do with how the app will look as how it performs. In larger app development projects, a separate design team will often work in parallel with the code development team. And Google has created a separate, large, and well-done section of the developer's website dedicated to design. We've already looked at portions of the design pages. The home page for this section is shown here. And since this course is focused on code development, we won't go through the design guide in detail. However, we will refer to it as we discuss various user interface code development topics. In addition to the design guide, Google includes a graphical layout editor with the Android Eclipse tools. Let's take a look at it using our first app. We'll open the layout, and by clicking on the Graphic Layout tab, we see a high-quality display of the screen and sets of options for adding elements to the display screen. So, for example, we could add a ratings bar. Let's expand this a bit here, make that a little bigger. And here we see the ratings bar. Click on that, pull it over into our display. And then if we wanted to, we could center it by clicking on this drop-down menu, click on Center Horizontal, and we see the ratings bar has been centered. And now if we click on the XML tab, we see the ratings bar XML has been added with the appropriate attributes. Since in this course we're focused on coding Android apps, we won't be emphasizing the graphical layout tool. I suggest you experiment with it on your own, maybe using our first app, to get a feel for the graphical layout tool set. Note that using this tool, you're only getting the XML for the screen and not the Java code to access it. However, you do get a started access. Note that in our ratings bar element, an ID has been created, rating bar 1. This ID can be used to access this element from Java code, as we saw in the lesson on accessing resources in the Resources chapter. On the Developer Tools webpage, click on the Graphical Layout Editor to the right, and you'll see a good summary of the tool's capabilities. So this is a great tool for helping design your app screen displays, and it's particularly useful if you're using non-code developers on your design team. They can focus on creating visual elements without worrying so much about the underlying code. In this chapter, we'll use the API Demos app to demonstrate a number of user interface capabilities. The Views API demos are focused on the user interface, and there are a large number of them. They account for almost half of the over 300 API demos. And the Views demos have a number of secondary and even tertiary groups. And during the user interface lessons, we'll be looking at a number of them. That's our lesson on the user interface chapter, and let's continue with the lessons. In this lesson, you'll learn how to develop user interface layouts for your Android apps. Layouts control the visual structure of a screen display. For example, let's look at the Common Layouts section of this Layouts page on the developer's website. 3 common layouts are linear, relative, and web view. The linear layout organizes elements in a horizontal, as you see here, or vertical sequence, one after the other. A relative layout organizes elements relative one to the other. So, for example, this element is underneath this element and beside this other one. And a web view displays a web page, and we'll look at web views in detail in a later chapter. Now let's take a look at an example of a linear layout. We'll use the demo on our worksheet at line 229, a vertical layout with the Java code name Linear Layout 1. Let's start it up in the emulator by clicking Views, Layouts, Linear Layout, Vertical. And in Eclipse, in the Views source, we'll open the Linear Layout 1 Java file. In the Java code, at line 35, we see a set content view using Linear Layout 1. So in the Layouts folder, let's open Linear Layout 1. And in line 19, we have the declaration of a linear layout, and in line 20, the orientation of vertical. And there are 3 text views, and they're in order, and you can see how they show up in the app screen. The top text view, the middle view, and the bottom view. So in a linear layout, the views are stacked one after the other, and you can see that text over here. Top view, middle view, bottom view. Next, let's take a look at a relative view. Let's go back in the demo and select Relative Layout and Vertical. And this demo is on line 233 in the worksheet, and it has a Java code name of Relative Layout 1. Now back in the Views Java folder, we'll open Relative Layout 1, and we see that it uses the layout, Relative Layout 1, so we'll go back and open that. In the Relative Layout XML code, in line 21, we have the declaration of a relative layout, and there are 3 text views. Let's look at each one. Each of the views uses layout attributes to position themselves on the screen. In View 1, the Layout Align Parent Top is set to true, and this attribute places the view just under the top of the parent view, which in this case is the screen display itself. So over here we see it's positioned right there at the top. In View 2, we have the Align Parent Bottom attribute set to true, which places this text view at the bottom here. You see it in green on the app display. And in View 3, we have in line 49, Layout above View 2, and in line 50, we have Layout below View 1. So it's putting the center vertical text in between the top and the bottom. Now, as you might imagine, there are a lot of different ways to position screen objects relative to one another. And as with the other type of views, there are many different attributes that can be used to alter the appearance of the layout and the objects on the screen. In this course, we won't have time to go through all of these individually. So you need to learn how to look up the options on the developer's website. And let's use the relative layout to see how this is done. First, use the search feature on the website to search for the type of element you're working with. In this case, it's relative layout. So let's enter that. And what do we get? We see a reference to a page for relative layout params, or layout parameters. That looks like what we're looking for. Click on that. And here they are. This is exactly what we're looking for. It's a list of the XML attributes for positioning. Now, it's a fairly long list, and as we'll see in the next lesson, the graphical layout editor can help deal with the magnitude of these options. But that's our lesson on layouts, and next we'll learn more about using the Android tools to aid in developing your layouts. In this lesson, you'll learn how to use API demos along with the graphical layout editor to create display layouts. As you can see on the worksheet in the layouts entries, starting here, there's a sizable number of different types of layouts and variations within those. To get a handle on all of this, let's first take a quick look at the layout API demos. And there are too many subgroups and demos to go through every one, so we'll just look at samples of each different type. So to find them, we click on Views, Layouts, and we'll click on Baseline. The baseline demos display simple examples using attributes such as gravity to determine where to place elements on the screen. So for example, the bottom demo places elements along the bottom of the screen. Grid layout demos use a grid view tag to arrange elements, such as in this simple form, placing elements inside of a grid. The linear layout and relative layout we've already looked at in another lesson. Scroll view demonstrates scrolling lists, such as in this long demo. And table layout demo shows options using the table layout tag for using rows and columns to display data, such as in this basic demo, where you have 3 rows and 3 columns. And the approach to implementing these layouts is basically the same as we've seen in the linear and relative layouts we explored in a previous lesson. The Java code uses a setContentView method to establish a layout in which the type of layout is declared on the detailed attributes that are included in the various tags within the layout XML. Sounds simple. However, one of the challenges in developing layouts and all of their piece parts is the vast number of options available for types of display objects, positioning them on the screen, and formatting, and so forth. And one approach to handling this complexity is to use the API demos coupled with the graphical layout editor. So it works like this. First, you'd use the API demo worksheet and the API demo app to identify a starting point that's the closest to what you have in mind for your screen display. So let's say you wanted a simple table layout. In line 237 on the worksheet, we see a basic table layout. So if we click Table Layout and Basic in the demo, we see that display. And in the worksheet, we see that the Java file name is Table Layout 1. So now let's look at the code in Eclipse. In the Views source folder, we look for Table Layout 1. We'll open it. And we see that the setContentView uses table_layout_1. We'll go back and open that in the Layouts. Table Layout 1, there it is. And if we click on the graphical layout, we see the screen with the options for manipulating the objects on the layout screen. So let's expand this so we can get a better view, and we can increase the size. And let's say we wanted to add a row. So here's the Add a Table Row button. We'll click on that. And now let's say we wanted to add a chronometer to this row. Here's the chronometer. Click and hold. Move it over here. We're going to put it in the row that we just added. And there it is. And now let's look at the XML. And we see that it's added our chronometer tag and attributes. And we also see that it's flagging an error. And the error is basically telling us that we need a string for chronometer instead of hard coding it in the text attribute. So from here, we could add a string in our strings file, as we saw in the lesson on providing resources. So what the graphical layout editor did was to choose basic attributes for our chronometer object, the ID, width, height, and text. And it also created a starting point for the other rows and columns in our table. Now, if we go back to the graphical layout, click on our chronometer, we see the attributes associated with it. And we could, for example, change the text size to, let's say, 30 SP, and we see that the text size increased in the display. And if we go back to the XML code, we see that the text size attribute has been added at 30 SP. That's our lesson on creating layouts using the API Demos and Graphical Layout Editor. And these tools can be a big help in mastering user interface design and implementation. In this lesson, you'll learn how to display user interface input controls for your Android apps. In this lesson, we'll only be looking at how to display the controls, not react to them in Java code when they're activated by the app user. We'll cover that aspect in the next lesson on input events. The Android website has a good set of web pages dedicated to input controls, and the main page is shown here. At the bottom of the page is a list of some common controls: button, text, checkbox, radio buttons, toggle buttons, spinners, pickers. And there are also some useful links to related classes for each one over here on the right. In the API Demo app, let's take a look at a common control, the button. You've already seen buttons in action in some of the previous lessons. You can find the button demo on the worksheet. To do that, let's filter on the demo name column. We'll put in button. And we have a couple of entries, and we'll use the one in line 286 that has the Java code name buttons1. In the demo, we'll click on the views group and buttons, and we see 3 buttons, and if we click them, the third one causes the blue indicator to come on and the text to change from on to off. And let's take a look at the code. So in the views Java code, we'll open buttons1, and it uses the layout buttons1, so we'll open that in the layouts folder. And let's look at the XML code. And here we see the 3 buttons defined. Notice that the second button in line 35 has a style defined as small, and the third button is defined in line 40 as a toggle button, which provides the on-off behavior when it's clicked. So it's not the Java code in our app that's causing this button to change, but the Android system itself. As I said, we'll be looking at how our app Java code interacts with input control displays in the next lesson. The API Demos app doesn't have a separate grouping of input controls, so I'll point out where you can find some of them on our worksheet. A number of the input controls, such as the buttons demo we just looked at, are demonstrated in this group of demos here that don't have a secondary or tertiary grouping. In other words, you access them straight from the Views screen in the demo app. For example, here's the buttons demo. And there are also some input controls demonstrated in the autocomplete group, which is here. And you'll find some in the controls group right underneath autocomplete. For example, let's look at controls, pick the light theme, and you see we have checkboxes demonstrated, radio buttons, stars, on-off, radio button list, and so forth. So that's our lesson on input controls, and now let's look at how they're responded to using input events. In this lesson, you'll learn how to handle user interface input events in your Android apps. Input events are responded to using event listeners. And we studied listeners in the previous lesson on listeners and toasts, so I suggest that you review that lesson as a background to this lesson. And there are a number of different types of events that have listener interfaces. Some of them are listed on the Input Events webpage under Event Listeners, and they include onClick, where the view.onClick listener is called when a user touches the item or focuses on the item with navigation keys or trackball and presses the Enter key or trackball. And you can see onClick in action in the previous lesson on listeners. On long click is the same as on click, but requires a hold of the touch or key for 1 second. On focus change, the view.onFocusChange listener is called when the user navigates onto or away from the item using the navigation keys or trackball. On key, the view.onKey listener is called when the user is focused on the item and presses or releases a hardware key on the device. On touch, the view.onTouch listener is called when the user performs an action qualified as a touch event within the bounds of the item. The onCreateContext menu, the listener is called when a context menu is being built as the result of a sustained long click. In the API Demos app, code for handling input events is embedded in a number of the modules that demonstrate input controls. For example, let's look at the Views group at the Switches demo. Let's go to Views and Switches. And we see a number of input controls. One of these, the monitored switch, has a listener associated with it. So when we change it, we see a toast down here. I don't know if you saw that. I'll do it again. It says monitored switch is off. Click it again. It says monitored switch is on. And let's look at the Java code. In the worksheet, we see that the Java code name is switches. So in our views source, we'll open the switches file. And on line 39, we see an onChecked changed listener being set, and the onChecked change code is here below. It's being done with an override to the onChecked change method in line 44. And we see the code creating the toast in line 45. And one way to determine which listener to use for an event is to consult the developer's website pages for the various input controls. For example, if we look in the API guides under User Interface and Input Controls, toggle buttons, at the bottom of the page, we see a link for the onCheck Change Listener. If you don't know where to look on the developer's website for a particular type of input event listener, try using the search capability. So for example, go back up to the top and search on Switch Listener. We see that the first entry is for toggle buttons, which is where we just were. So with a bit of research, you should be able to find a code pattern you can use as a start for creating an input event to match an input control in your user interface. That's our lesson on input events for responding to input controls. Let's continue and look at some more user interface elements. In this lesson, you'll learn how to develop options menus for your Android apps. The menus page on the developer's website is shown here, and this is a good resource for background and details about menus, including options menus. The menus are a common and important user interface component. They provide a convenient way for users to select options for app actions in addition to navigation buttons built into the app screen displays. And there are three basic types of menus: options menus, context menus, and pop-up menus. So let's look at options menus, and we'll cover the other two in the next lessons. In the contents overview on this page, click on Creating an Options Menu. And beginning with Android 3.0, API Level 11, Android devices are no longer required to provide a dedicated menu button, and Google is encouraging developers to migrate away from a dependence on a traditional 6-button menu, such as shown here, and instead provide an action bar to present common user actions, such as the one shown here. To see how options menus work, let's check out an options menu API demo. Using the demo's worksheet, let's find the options menu entry, and we'll filter the demo name for options to do that. Actually, we have filter on. We can just click here. And we find an entry at line 62, and we see the Java code name is fragment menu. So let's first fire up the demo. We'll click on App, Fragment, and Menu. And the demo builds menus from two fragments. And when there isn't room in the action bar up here for the second menu, it's replaced with a drop-down menu. So if I uncheck both, there's no menu shown. If I check menu 1, we get the two options for menu 1A and 1B. And if I check only fragment 2, we have the menu here that shows up. So Android is managing the options menu availability on the action bar, and we'll look at action bars in a coming lesson. Now in the app source, let's open fragment menu. It's in the app group. So we come down to fragment menu, open that. And I'm going to skip over the code on fragments as they'll be covered in a separate lesson. So we'll focus on the code pertinent to creating the options menu. At line 106, the set has options menu setting to true is used to indicate that there's a menu associated with the first fragment. In line 110, we have the onCreateOptions menu method that sets up the menu items using the add method twice, once in 111 and once in 112. And notice the show as action if room attribute that tells the Android system to show this item as a button in the action bar if the system decides there's room for it. As we see over here, that's the button. In lines 124 and 129, we have the same code for the other fragment. And the options menus are then displayed by the system when the fragment they're associated with is displayed, depending on the status of the checkboxes, which are processed in the update fragment visibility method starting in line 87. To respond to the selection of an options menu item by the user, use the onOptionsItemSelected method. And let's take a look at how to do that. How to respond to options menu item selection is explained on the developer's website in the API guides, user interface, on the menus page. In the document summary to the right, under creating an options menu, click Handling Click Events. And this shows an example of using an override of the onOptionsItemSelected method where you would respond based on the item ID, which you retrieve using the getItemID method here for the menu item in the parameters. And then you can use a switch method to activate the code you want to associate with each item ID. As an aside comment, you'll see lots of code examples like this on the developer's website, and they make a good combination with the API demos. The API demos give you a good working base of code into which you can insert additional code, such as this code for handling option item selections. And when you add code blocks to your base code, you're likely to have to do a bit of debugging to get the new app code to work properly. And you can review our previous lessons on debugging in Eclipse if you need a refresher on these topics. That's our lesson on options menus. We'll look at other types of menus in the next lessons. In this lesson, you'll learn how to develop pop-up menus for your Android apps. To get started, let's filter the demo name column of our worksheet for pop-ups. Filter. And we get an entry in line 294. We see that the Java file name is pop-up menu 1. So let's take a look at the demo in action. Click on Views, Pop-up Menu, and click on Make a Pop-up. And we see our menu, and notice that it's displayed next to the button. So pop-up menus are associated with the button or the list item that creates them. And we can click on the items to get a toast telling us which item was selected. In the Views source code, let's open pop-up menu 1. And we see in line 36 that in its setContentView method, it's using the layout pop-up menu 1, so let's open that. And the layout XML, notice the definition of a button starting in line 20. And in line 23, there's an onClick attribute defining the name of the method that will be executed when the button is clicked, on pop-up button click. Back in the Java code, we see the on pop-up button click method starting in line 39. So this is the code that'll be executed when the button is clicked. So let's see what it does. In line 40, a pop-up menu object is instantiated. In line 41, the getMenuInflator method is used to inflate the pop-up menu. And let's take a look at the pop-up menu in the Menu Resources folder. So in the Menu folder, we see it here. Double-click on pop-up. And here we have the details of the menu itself with items for search, add, and edit. And you notice in edit, there's a submenu. So if we click on edit, we see a submenu item. We can click on that, and we also get a pop-up saying that the share button has been clicked. And notice that each entry in the XML specifies an ID, an icon, and a title. Now back to the Java code. And in lines 43 and 44, a toast is made that includes a reference to the specific item clicked. It uses the getTitle method to get the name of the menu item. In a real app, it's here that you'd take actions based on the menu item clicked. And in line 51, the pop-up menu is displayed using the show method. So that's our lesson on pop-up menus. Let's move on and look at context menus in the next lesson. In this lesson, you'll learn how to develop context menus for your Android apps. To get started, let's filter the demo name column of our worksheet for context. And we get an entry in line 55, and we see that the Java code name is Fragment Context Menu. So let's first fire up the demo. We'll click on App, Fragment, Context Menu. And the demo builds a context menu on a long press of the button. So we'll give it a long press, and there we get our menu. And note that the menu displayed is not shown next to the button, as was the case with our pop-up menu. Now in the App Source folder, let's open Fragment Context Menu. I'm going to skip over the code on fragments, as they'll be covered in a separate lesson, and we'll focus on the code pertinent to creating the menu. In line 53, we inflate the menu using a fragment context menu layout. Note that the context menu is defined in the Layout resource folder. So in the Layout resource folder, let's open Fragment Context Menu. And Fragment Context Menu sets up the button we see saying Long Press Me. Here's the button definition starting in line 30. Back in the Java source code at line 54, we use the register for context menu method to cause the onCreateContextMenu menu method below to be invoked when the long press button is pressed. Notice that the long press ID from the layout XML is used as the identifier for a trigger of displaying the menu. We see that ID here in line 30 of the XML long press. And it's referenced here in line 54 of the source code. And in the source code at line 59, we have the method that sets up the menu items. This method adds two items to the context menu that we see appear, labeled Menu A and Menu B. To see what these parameters mean, let's pull up the documentation for the add method. And I'm going to expand this window to do that. So here's the parameters described, and the first group ID is the group identifier that this item should be a part of. And it can be used to define groups of items for batch state changes. Normally, you should use none if an item should not be part of a group, which is what we're doing. So it says menu.none. The second parameter, item ID, is a unique item ID, and we're using A underline item and B underline item as IDs. The third parameter is the order for the item, and you use none if you don't care about the order, and we're using none. And finally, the fourth parameter is the text to display the item, and we're using Menu A and Menu B. Now down in line 66, we see the onContextItemSelected method that's invoked when a menu item is clicked, and it uses the getItemID method to determine the ID to be used in the switch below that activates the code we want associated with each item. That's our lesson on context menus, and we'll continue with more user interface lessons. In this lesson, you'll learn how to display and react to action bars. The developer's website has a very good page in the API guides on action bars, and it's shown here. You can check it out for additional detailed information. We're going to concentrate on action bar code in an API demos app. So in the demos worksheet, let's filter the demo name for action bar. And we find 4 entries. And let's look at the action bar mechanics demo on line 18, which has the Java name action bar mechanics. Let's fire it up in the emulator. We'll click on App, Action Bar Mechanics. An action bar is a standardized place to provide action options for the user, such as navigation, search, and activating tasks. And you see an action bar up here on the top of the app screen. So if we click on this share icon, we get a toast, selected item action button. And if we click on the drop-down menu, we see another item called normal item, and we get a toast, normal item selected. Now let's look at the Java code, which we find in the app folder with the name Action Bar Mechanics. It's right here. In the onCreate method for the activity in line 42, we use the request feature method to activate the action bar feature, designated here. Starting in line 46, we have the onCreate options menu method that sets up the action bar. In line 51, we use the menu add method to add an item that will always appear in the drop-down menu. See, it has the label normal item. So in the demo, when I click the drop-down, we see the normal item appear. In line 53, we declare a menu item and use the add method to add a button called action button. So in the demo, when I click the share button, we get the toast. In line 58, we use the set show as action method that sets the attribute show as action if room, so that the share action button will show up in the action bar if there's room. In line 63, we use the set icon method to set the share icon to be displayed for our action item button. It's designated here. And in line 69, we have the code that's executed when an action bar item is clicked. It overrides the onOptions item selected method and makes a toast using the title of the item retrieved, and it uses the getTitle method to find the title. And it's here that you'd add code to take actions based on the item selected. So that's the basics of setting up an action bar. It's not very complicated. Remember, the heavy lifting of displaying the action bar properly depending on the size and layout of the mobile device is done by the Android operating system. And let me make a point about the way we're going through not only this code on action bars, but how we'll be exploring the Android features in this and chapters and lessons coming up. First, by the very nature of object-oriented programming, you shouldn't have to understand all the underlying detail of how a given class or method accomplishes its result. So as I point out what classes and methods are used, I won't discuss every detail about them. The Android developer's website has a huge amount of documentation on classes and methods that you can use to dig into as far as you need to or want to. Now, sometimes a method won't work or won't work the way you think it should, so you'll have to dive into the details to figure it out. Sometimes you'll just be curious about the full scope of a class or method. With thousands of Android classes and methods in total, we don't have the time to address all the details, and you'd probably get quickly bored going through all that material anyway. In my opinion, Android is very much a learn-as-you-go technology. Each new app you develop will take you into new aspects of Android. In addition to explaining specific Android capabilities in this course, I'm also trying to give you the tools and knowledge you need to continue learning. Something like the old saying of teaching you how to fish instead of doing all the fishing for you. And there's just too many Android fish out there to do all that for you anyway. So that's our lesson on action bars, and let's continue with more user interface topics. In this lesson, you'll learn how to store, display, and modify the settings for your Android apps. In addition to the settings page shown here in the API Guides section of the developer's website, there's also a settings design guide page to help you decide how to organize your settings. There's a link to it here. And we'll be focusing on the API Demos app code related to settings. Settings are values used to control various aspects of your app. Settings for an app are handled just like settings for your device. On the home screen of the emulator, if we click on the Settings app, we see the first level of the settings hierarchy for your device. So if we click on Display, we get the settings to control the look and feel of the display screen. And if we click on Brightness, we get a dialog screen for altering the brightness level. And your apps should always use the preference APIs to manage its settings. And the terms settings and preferences are sort of synonymous. The term settings is more of a user external perspective, and preferences is more of a developer internal term. This lesson on settings and the next on preferences are really addressing different aspects of the same topic. In the Demo Apps worksheet, there's a main group of preference demos that address settings and preferences. We'll look at the fragment demo here in line 163 that has a Java file name of fragment preferences. So let's fire it up in the emulator. We'll start up our API demos, click on Preference, and then Fragment. This display of app preference settings shows a variety of preference types, and we'll go over these in a minute. Let's take a look at the Java code. In the Preference folder, we'll open Fragment Preferences. In the onCreate method in lines 36 and 37, the fragment defined below, prefs fragment, is displayed as the main content you see on the demo screen, and we'll leave the details of fragments for that lesson. In line 41, the prefs fragment class is defined extending preference fragment. The preference fragment class shows a hierarchy of preference objects as lists, as we see on our app display screen. These preferences are automatically saved to shared preferences as the user interacts with them. So for example, when I change this checkbox, the change is automatically updated in the app preference settings. So the Android system is doing a lot of the heavy lifting in managing your preference settings. Also, the preferences shown follow the visual style of system preferences we looked at the start of the lesson. So there's continuity between the look and feel of the preferences in your app with the system and other apps that also use the preference fragment class. In line 48, the preferences definitions are loaded from the preferences XML file. Let's go to the XML folder and open the preferences XML file. We have the preferences XML file here. We'll double-click it to open it. So this is the code that defines the structure of your preference settings. Let's go through it and compare the XML code to what we see on the screen. In line 19, the preference screen tag declares that this is a preferences layout. In lines 22 through 23, the preference category tag declares a category grouping and uses the title defined in the inline preferences string. And we see the inline preferences title showing here in our app display. The inline title means that we can change the values right here in the list, such as checking and unchecking the checkbox. In lines 25 through 28, a checkbox preference is defined using a unique key, title, and summary string that says this is a checkbox, as we see here. In lines 32 through 33, another preference category is defined as dialog-based preferences. These require clicking them, such as the edit text preference, and then getting a dialog screen for making a change, such as we have here my data. We could change that to something else. In lines 35 through 39, we have the definition of this edit text item that we just looked at. In lines 41 through 47, the list preference item is defined. Click the list preference and you see a radio button list to choose from. We can change that. And notice the reference to a couple of arrays here. And let's open the arrays XML. And scroll down to Entries List Preferences. So here we have the string array entries list preference, and below it entry values list preference. And these define this radio menu. In line 51, back in the Preferences XML, there's another preference category defined, Launch Preferences. In lines 57 through 62, a preference screen is defined that sends the user to a new fragment of preferences. Here. In lines 75 and 76, a preference screen sends the user to a web page. Here. Now, this is failing in the emulator, so I won't click it. I tried it on my phone and it works okay. So the failure seems to have something to do with the emulator implementation of this feature. In lines 85 through 96, a checkbox preference is defined with a child dependence that shows if the parent is clicked. So we see over here, if this is unclicked, the preference below it doesn't show or is grayed out. And if it's clicked, it does show. So that's our lesson on settings. In the next lesson on preferences, we'll continue to look at these capabilities. In this lesson on preferences, we'll build on the information in the previous lesson on app settings. Let me show you the documentation on different types of preferences on the developer's website. First, search on Android.preference. And click on this link to the package summary. And then scroll down to the classes. And here we see links for checkbox preference, dialog preference, etc. Let's click on checkbox preference. And here we find a description of the XML attributes possible, including attributes inherited from the preference class. So the set of possibilities for preference settings is pretty large. I think the best approach for learning all of these is for you to be driven by the apps you'll be developing and research the preferences as you need them. In the meantime, you can scan through the developer's website preference pages I've pointed out. You can also use the Preference API demos to see more of preferences in action. In our worksheet, we can see we have 9 preference demos without any secondary or tertiary groupings. And let's check out what the demos can do. So here's the preferences demos, and we'll go through them. Preferences from XML demonstrate displaying preference values stored as XML values. Launching preferences demonstrates launching the display of preferences as the result of a button click. Preference dependencies demonstrates displaying hierarchical preference values triggered by checkbox event. Default values demonstrates changing preference default values, such as checkbox, changing text, and lists. Preferences from code demonstrates creating preferences using Java code. And note that using a field such as text, you can store values that'll be retained across uses of the app. And this is how preferences become a storage option. You wouldn't want to use this for large amounts of data, but it's a great option for retaining small chunks of data. So, for example, you could have code that stores data in a text field, say my data or my data. And then when the app is restarted, so we save it and restart it, the text string is still there. Advanced preferences demonstrates changing preference values, such as clicking on my preference, it's changing it to 1.9, 1.11, and we have a haunted preference that's changing itself through Java code. Fragment demonstrates displaying preferences in a display fragment. Headers demonstrates stacking header displays. And finally, switch demonstrates changing switches and preferences. So that's our lesson on preferences, and coupled with the previous lesson on settings, you should have a good idea how preference settings work. In this lesson, you'll learn how to develop user interface dialogues for your Android apps. A dialog is a small window that prompts the user to make a decision or enter additional information. A dialog doesn't fill the screen, and they're normally used for events that require the users to take action before they can proceed. A couple of examples are shown here on the dialogues page on the developer's website. And in addition to this page, there's a dialogues design page that we can get to from this link here. And this includes some good insights into creating alerts, pop-ups, and toasts. And we're going to focus on code behind dialogues using the API Demos app. In our demo app worksheet, let's filter the demo name on dialog. And we get a number of entries. I'm going to use the demo in line 53 with the Java code name fragment alert dialog. Now let's fire it up in the emulator by clicking on App, Fragment, Alert dialog. If we click the Show button, we see a dialog window pop up with two buttons. Now let's open the demo in Eclipse. It's in the App Demo group, so in the App folder, we'll open Fragment Alert dialog. I'll go through the code now, but be prepared. There are a number of levels of functionality. From within the main activity, we'll be using a fragment manager to manage a fragment that contains the dialog that activates buttons. It's more nesting than you might expect for a seemingly simple display. We'll start at the top with the main activity. In line 36, the main activity is declared that displays the screen you see with a show button at the bottom. In line 41, the setContentView method uses the fragment dialog layout to display the screen. In lines 43 and 44, the text at the top of the screen is displayed using the setText method. Now, normally you'd put your text in the strings resource file, but text can be inserted like this using code. In lines 47 through 50, we have the code that sets up a listener for the show button at the bottom of the screen, and when it's clicked, activates the show dialog method, which is coming up next. In lines 56 through 59, the show dialog method generates a dialog fragment called new fragment and displays it using the show method. So in the app demo, if we press the show button, we see the dialog appear. And the text string you see here is defined in the alert dialog two buttons title entry in the strings resource file. In lines 62 through 69, methods are defined to take actions when the buttons on the dialog are pressed. So in the app demo, if we press the OK button, the do positive click method is activated, which creates a log message positive click. In lines 74 through 81, a dialog fragment named myAlert dialog fragment is defined. Note that this object is used in line 57 above. In line 81, the method returns a new instance of myAlert dialog fragment when it's used in line 57. In lines 84 through 105, we have the guts of the dialog. It overrides the onCreate dialog method of the dialog fragment. In lines 88 through 106, an alert dialog is built using constructors for an icon, title, positive button, and negative button. Let me expand this so that you can see all of that code. Note that the code to set up the buttons is a somewhat complex sequence. For example, in lines 91 through 94, the string alert dialog OK is one parameter, and the second parameter is the 3 lines of 92 through 94, which set up an on-click listener for the button, which activates the do positive click method defined above. So in summary, there's a lot going on in this code, and this is one of those instances when it's great to have a code pattern to work from instead of having to construct all of this from the ground up. That's our lesson on dialogues, and there are a number of variations on dialogues that you can see on the developer's website dialog pages. In this lesson, you'll learn how to develop notifications for your Android apps. A notification is a message you can display to the user outside of your application's normal UI. And when you tell the system to use a notification, it first appears as an icon in the notification area. To see the details of the notification, the user opens the notification drawer, and then both the notification area and the notification drawer are system-controlled areas that the user can view anytime they want. And there are two types of notification views, normal and big. A normal view appears in an area up to 64 dp tall and looks like this, and it can contain an icon, title, content info, small icon, and time. And a big view can contain all those elements plus extra information from the app, such as email inbox information in this example. So let's look at an example from the API demos. In the API demos, there's a secondary grouping in the app group for notifications. There's 4 of them, as you see here. And we'll use the incoming message app to examine notification code. That's in line 72 in the worksheet. So let's fire it up in the emulator. We'll click on App, Notification, Incoming Message. And it demonstrates 2 ways of initiating a notification. The first displays a notification that switches to the app in a new activity stack. So let's click the Show App Notification button, and we see the message appear here at the top. Now we'll pull down the drawer, and we see the notification in a normal view. Click on the notification, and we get an expanded view telling us to notice that the status bar icon has now disappeared. Now let's go back and try the other option. We click on Incoming Message again. Now we'll click on Show Interstitial Notification. We get the message at the top. Pull down the drawer. Click on it. And this time we have a message telling us to click another button that sends us back to the same screen we saw when we pressed the previous button. Now, what's happening in this app will make more sense when we look at the code, so let's check that out now. In the app Java source folder, we'll open Incoming Message. In line 42, the screen layout is established using the Incoming Message XML file. In lines 44 through 54, listeners are set up for 2 buttons. The first executes the method showAppNotification, and the second show interstitial notification. And in lines 66 through 93, an array of intent objects is created that represents the activity stack for the incoming message details. This is used in the show app notification method, and it's then also used in the second interstitial button method, and we'll see how that works. What's going on here is that you're giving the Android system a traceback from an app so that when the user is taken to the app and then they use the back key, they'll end up where they think they should. So for example, back here in this display, if we use the back button, it takes us back to this list of demo options. So when we click the incoming message and then show app notification and then the message, we've been placed inside of an app. And now when we hit the back key, we're taken to the demo screen. And that's because of the number 2 entry in the intents array, and the successive back keys step us through the rest of these intents. Now let's look at the show app notification method starting in line 101. Let's expand this out. In line 103, it creates a notification manager using the getSystemService method with the notification service parameter. In line 106, a from name is created using Joe. In lines 107 through 111, a message content is randomly chosen from 3 alternatives. In lines 118 and 119, a pending intent is created using the make message intent stack we created above. In line 122, a string to be displayed in the notification is created. In lines 125 through 126, a notification object is created using a drawable ticker text, which is scrolling text, and the current time. In line 129, the information to be displayed in the notification is specified. In line 134, notification options such as sound and vibration are set to the default values. In line 141, the notification is displayed. Now let's look at the second way of implementing a notification in this demo. Starting in line 150, the show interstitial notification method is defined. In lines 152 through 161 and lines 175 through 194 are basically the same as the show app notification method we've already examined. The difference between the two methods is how the intents are handled in lines 167 through 172. In line 167, it creates an intent for the class incoming message interstitial. So let's open the Java source for that class in the app folder, incoming message interstitial. In that class, in lines 38 through 43, it creates the display with a button listener. Let's go back to the app. We see if we click Show Interstitial Notification, it's creating this. It's responding to this button. And if we click the Switch to App button, we're at the screen showing the details. To get us to that screen, the code is in lines 53 through 61. And this code uses the make message intent stack from the incoming message class we've already studied. So in this lesson on notifications, we've seen a lot of somewhat intricate handling of intents. Now for the basics of intents, you might want to go back and review our lesson on intents. Sometimes, as I think is the case with the code we've examined here, you just need to spend some time studying the code to let the concept sink in. When it comes time to use notifications in your apps, you can use the code pattern from this demo as a starting point, and with some persistence, add your own code into the mix. That's our lesson on notifications. Now let's continue with more user interface topics. In this lesson, you'll learn how to display and access the contents of lists in your user interface. Lists are addressed on the developer's website on the List View page shown here, under Layouts in the API guides. List View is a view group that displays a list of scrollable items. The list items are automatically inserted to the list using an adapter that pulls content from a source, such as an array or database query, and converts each item result into a view that's placed into the list. There's also a page on the design guide section of the website in Building Blocks that discusses lists. And lists are a very common element and used in many apps, and there are a lot of variations on list displays. So let's begin by looking at lists in the API Demos worksheet. In the Demos worksheet, there's a large secondary group of list demos shown here within the Views primary group. And let's look at a basic list display demo. I'm going to use the array demo in line 251, and it has the Java file name of list1. And notice that there are 17 list demos with Java file names of list1 through list 17. Now let's start it in the emulator by clicking Views, Lists, and Array. And we see a list of cheeses that we can scroll through. Now let's open it in Eclipse. In the View source folder, we'll open list1. And the first important thing to notice in line 28 is that the class list1 extends the class listActivity. And listActivity is an activity that displays a list of items by binding them to a data source such as an array or cursor, and as we said, activates event handlers when the user selects an item. So what this means is that there is a lot of functionality for handling and displaying lists built into the list activity class. And notice that we're not using our typical set content view method to create a screen display. That functionality is built into the list activity class and its methods that we'll be using. So in the onCreate method in line 36, we're using the setListAdapter method to set up our list display. We're passing one parameter to the setListAdapter method, and that's an array adapter that we create using the arrayAdapter class. To create the array adapter, we use three parameters. The first is the current context, this. The second designates the format for each list item. And we designate a format that's defined for us in the simple list item 1, designated here. And we know what the format looks like from the demo screen. Each item contains a name with a line separator between each entry. The third parameter is the name of a string array variable, mstrings, defined below in line 41. This statement uses the class cheeses. So let's open that class. And we see the string array S cheese strings is defined with this rather huge list of cheeses. I don't know about you, but I didn't realize that there were that many different kinds of cheeses. Now we know. Back in the list 1 source, in line 38, we use the getListView and setTextFilter enabled methods. The setTextFilter enabled method, set to true, would allow us to use a key. If we had a hard keyboard available and we entered a character, the list would move to the selection of cheeses that begins with the characters we enter. And if we look at the list view class on the developer's website, we see a long list of set methods for altering the appearance of the list. And there are more in the ABS list view base class, including our set text filter enabled. That's our lesson on lists, and there are a lot of variations on list displays that you can explore using the list API demos. To understand how they work, go through an investigation of their classes, methods, and parameters like we've done for the array list example in this lesson. In this lesson, you'll learn how to use fragments in your Android apps. A fragment represents a behavior or a portion of a user interface and an activity. You can combine multiple fragments in a single activity to build a multi-pane user interface and reuse a fragment in multiple activities. You can think of a fragment as a modular section of an activity, and it has its own life cycle, receives its own input events, and which you can add or remove while the activity is running. Sort of like a sub-activity that you can reuse in different activities. This page on the developer's website has a lot of good information on fragments. And one of the common uses of fragments is to create layouts that'll adapt to different device screens. In this example from the website, we see a layout appearing in a tablet with a list on the left and the details of a list item appearing on the same screen. On a handset with a smaller screen, the list and details appear on separate screen displays. And we're going to focus on code from the API demos to explore fragments. And let's begin by looking at fragments in the API demos worksheet. In the demos worksheet, there's a large secondary group of fragment demos shown here within the primary app group. Now let's look at a basic display demo. I'll use the hide and show demo on line 59, which has the Java file name of fragment hide show. So let's see what this does in the emulator. We click App, Fragment, and Hide and Show. When we click the buttons, the text disappears and then reappears. In the top button example, it's the fragment that's saving and restoring the text. And in the bottom button, it's the text view that's doing the saving and restoring. And this will become clear as we look at the code, which we'll do now. In the app source folder, we'll open fragment hide show. First, in line 36, we have the main activity, fragment hide show. In line 39, we have the onCreate method for the main activity, and we're going to be building multiple fragments within this activity. In line 41, we use the setContentView method with the fragment hide show layout to initialize the screen. So let's open that layout. So I scroll down in the project directory, open the resources folder, open the layout folder, and double-click on the fragment hide show XML file. In line 19, we declare a linear layout. In line 24, we have the text view for the title text. In line 29, we have another linear layout embedded under the first linear layout. In line 33, we have the top button in our layout with an ID of frag1 hide. In line 37, we have a fragment with the ID fragment1. And in lines 43 through 55, we have the same layout defined for the second button and fragment. Now let's go back to the Java source. In line 45, we create a fragment manager using the getFragmentManager method. In lines 46 and 47, we're using the addHideShowListener method defined below to create listeners for our two display buttons. In lines 50 through 67, we have the method that creates a listener for a given button ID. In lines 53 through 65, we have the code that's executed when the button is clicked. In line 54, a fragment transaction, which is an API for performing fragment operations, is initiated using the getFragmentManager method. In lines 55 and 56, a fade in and out custom animation is set up for the fragment. In lines 57 through 63, action is taken when the button is clicked. If the fragment is currently hidden, the show method is used to display it, and the setText method is used to change the button text to hide. If the fragment is currently displayed, it's hidden with the hide method, and the button text is changed to show. In line 64, the commit method is used to cause the fragment changes to take place. Now let's look at the code that defines the fragments. In line 69, we have the class declaration for the first fragment, which extends the fragment class. In line 70, a text view variable is declared to hold the text in the fragment display. In line 73, we have an override of the onCreateView method of the fragment class. And the system calls this method when it's time for the fragment to draw its user interface for the first time. To draw a user interface for your fragment, you return a view from this method that's the root of your fragment's layout, and we do this in line 84. In lines 75 through 77, the text in the fragment is set. And this code uses another layout labeled TextEdit. Let's open that. In lines 23 through 26, we have a text view with the ID MSG. And in lines 28 through 34, we have an edit text with the ID saved. Now back in the Java source, in lines 75 through 77, the text is set in the labeled TextEdit text view. I'm going to open this up so we can see the code better. In line 80, mTextView is set to the saved text view. In lines 81 and 82, if something has been saved in the bundle saved instance state, mTextView is set to that value. And in line 84, we return the view, which is set to the labeled TextEdit layout. In lines 88 through 93, we have the code that saves the mTextView text when the onSave instance state method is invoked, which is called before placing the activity in a background state. In lines 98 through 103, we do the same things for the second fragment we did as the first fragment in lines 72 through 77. And line 109 is different. Here's where we're using the text editor to save the text. And in line 110, we're returning the view. That's our lesson on fragments. A lot went on in a relatively small sample of code. You've seen how to check if fragments are visible or hidden, display fragments, change and save the contents of fragments, and include fragments in a layout. And this should give you a good base for using fragments in your apps. In this lesson, you'll learn about Android styles and themes. In the next lesson, you'll learn how to apply them to your apps. A style is a collection of properties that specify the look and format for a display. A style can specify properties such as height, padding, font characteristics, and background color. Styles are defined in XML resources that are separate from the XML that specifies the display layouts. Styles in Android carry out a function similar to cascading style sheets in web design. They let you separate the design from the content. In the content summary to the right, if we click on Defining Styles, we see an example of a style. The resources, style, and item tags are used to define the style attributes. In the style tag, the style is given a name, code font in this example, and an optional parent style is designated from which this style can inherit properties. In the item tag, the name indicates what Android attribute is being defined, and the value, such as fill parent, is included following the name. To invoke a style, it's named using the style attribute, such as in this code example. Style equals @style code font. A theme is simply a style applied to an entire activity or application. When a style is applied as a theme, every view in the activity or application will apply each style property that it supports. This page in the API guide of the developer's website provides a good deal of information on styles and themes. In the design guide, there's a style section that also addresses these topics. In order to bring a more uniform look and feel to Android apps, starting with release 3.0, Google introduced the Holo family theme, shown here in the design guide. In Android 4.0, Google has made the inclusion of the unmodified Holo theme family a compatibility requirement for devices running Android 4.0 and forward. If an app doesn't explicitly request a theme in its manifest, the system will determine the default theme based on the app's target SDK version. For values less than 11, it'll use the Android style theme, THEME. Between 11 and higher, to this point anyway, it'll use the Android style theme.holo. One approach you can take to implementing themes is to rely as much as possible on the Holo family standard and then add in style adjustments to your app where you think they're needed. For example, you might have a special kind of button that you feel needs a different color or shading. If you have separate coding and design teams, during code development, you might use the Holo theme exclusively while the design team works on style enhancements that you implement in the later stages of development. Google has put a lot of effort into developing the Holo theme family, so why not take maximum advantage of it? Now let's look at some examples from the API demos to see what some different styles and themes look like. In the demos worksheet, let's filter the demo name for theme. We have a number of entries in the controls secondary group within views and one in the tabs secondary group. Let's check out the controls group by quickly looking through each of these demos. So if we click Views, Controls, here we have the demos, and we'll start at the top with Light Theme. And notice the light gray background with dark gray accents. And if we check a checkbox or radio button, we get a green fill, yellow fill for a star, green indicators for on and off, and we have a drop-down list with radio buttons and text colors. And this is a demo on the emulator running API 16 or Android 4.1.2. Now let's look at it in an emulator running a lower level, API 8 or Android 2.2. So on the left, in level 8, we'll click on the light theme. And remember on the right, we have level 16. And you're seeing Here, on the right, the theme overridden by the holo theme for many of the elements. Comparing these two, you can see the evolution of some of the graphic elements. The newer holo theme on the right has flatter appearing objects with less shading and corner rounding and a gray background and a generally cleaner appearance. So if you compare the save button here with the save button here, you can see that cosmetic change. Now let's take a look at the others. So we'll go back and look at the dark theme. And if we go back here, we see the theme called default theme. So back in Android 2.2, those were the two options. So if we click on that, we're seeing a darkish theme, similar to but different than the dark theme here. So you notice the gray background is a little shaded. It's not quite as dark. Over here, it's solid black. And you notice a difference in buttons and checkboxes and so forth. Now let's go back to the control screen. And we can remove this emulator because we don't have any more examples over here to show. So if we look at the Holo Light theme, this uses the standard Holo family light theme. And the Holo standard family dark theme. And next we have a custom theme with a blue background. And finally, Holo or Old theme, which is another custom theme. It's using a theme variation defined in the app. So that's our lesson on styles and themes, and we'll see how to use them in your apps in the next lesson. In this lesson, you'll learn how to apply styles and themes to your Android apps. In the API Demos worksheet, let's filter the demo name for theme. And let's look at the code for the Holo Light theme demo on line 186 that has the Java file name of controls3. Let's first fire it up in the emulator. We'll click on Views, Controls, and Holo Theme Light. And now let's open the Java source. So in the View source folder, we'll open controls3. And we see that all it does is extend the class controls1. So let's go back and open controls1. In line 39, we see that the setContentView method is using controls1 layout. And we're focusing on styles and themes in this lesson, so we won't go over the other Java code. So let's go to the Layouts folder and open controls1. A first observation we can make is we're not seeing much in the way of style attributes as we scroll down. In line 60 and 61, we have some padding specs for a checkbox. In line 89, we have a style with a question mark indicator, and the question mark tells Android to use, in this case, star style from the currently applied theme. In a moment, we'll see where that currently applied theme, Holo Light, is specified. And further down, we have a few more references to styles within the current theme, for example, in line 113. So the heavy lifting for styling the look of this demo is being done by the Holo Light theme. Now let's see where the Holo Light theme is specified. And to find it, we'll look in the manifest. So we go back to the Package Explorer, go down to find the manifest. There it is. We'll open that. And let's first look at the Application tab, at the Application Attributes. And we see that no theme is specified. It's blank. In the Manifest tab, if we click on Uses SDK here, we see that the target SDK version is 16. So the system will apply the Holo theme, not Holo Light theme, at an application level. Back in the Application tab, down below in the Application Nodes, we'll look for our list of controls demo activities. So to do that, we'll sort them alphabetically. the API demos has a lot of activities, so they'd be hard to locate without this sort. So we go down to the views area. Here we see them. Let's expand this so we can see what we're doing. As I click on an activity, notice the information showing up on the right. In this case, the theme is showing as Android style theme.light. Now, if I click through the rest of the controls demo activities, and you watch over on the right, you'll see the theme change. Now let's go back to the Controls 3 activity that we're examining in our Java code. And the theme specified here is theme.holo.light. And this is the theme that's controlling the appearance of the emulator screen that we see here. Now I'll click the activity Controls 5, and we see that the theme is prefixed by style instead of, in Controls 3, it was prefixed by Android. This means that the Controls 5 style is defined in the styles file in the values resource folder. So let's take a look. We'll go to the values folder, and now we're going to open the styles file. And we have a number of style definitions, including one called custom theme. And that's the style that's applied to the Control 5 demo, specified here, style custom theme. So in our emulator, we look at the custom theme. We see this blue background, and go back to the code where the background is being defined with the color, custom theme color. And that is defined up here using the color element, and it's defined as B0B0FF. And we can use a website like the Adobe Cooler site at cooler.adobe.com. If we go to the Create page, and down here we put in that value, B0B0FF, we get the blue color from our background. And one last thing to mention, if you recall from our lesson on resources, you're able to specify different resources for different device versions. As an example, let's look in the resources values-v11 styles file. And we see that, for example, for API 11 and later, the Android theme.holo is used as a parent for theme.holo. And if we look in the main styles XML file, we see that in releases 11 and below, the Android theme will be used. Now, this lets you adjust the appearance of your app depending on the release level on the individual user's device. But that's our lesson on applying styles and themes to your Android apps. And the styles and themes are really a powerful tool for managing the appearance of your applications.